My name is Ruturli Chaudhary. I'm the team lead for Team 57190 of Team Metrominds. This is Metrosaathi, and our software application for the AI-powered induction planning and scheduling system. So basically, first, this is our admin dashboard, which will be our high-level overview of the entire application, whatever is going on, and whoever person is working. So currently, as you can see, that I am entering my details as admin. We start with admin@gmail.com, and after that, we will be putting our own password, which will all of this is, by the way, is role-based access. So we have protected routing enabled, which means that nobody can hack into the system as such as frequently. This is the main admin dashboard panel. As you can see, we all have our parameters. The trained model now essentially means that there will be a portion where the DL model that we have made our neural network based on, that DL model is going to be trained. As you can see, we have trained it properly when we have hit on the train model now option, API endpoint. After that, we move on to the individual parameters that can be shown that are updated dynamically. Finally, we have the complaints, jobs, and validation section. These complaints come from various different sources. There's Locopilot and messengers. These are the jobs, the job cards essentially that are required to be assigned to the people, and they will be seeing and validating it. Finally, we have the validation, which is essentially our two-factor verification system, that whether or not a job card has been successfully completed or not. So now we move on to what engineer dashboard section, which will be basically targeted towards the engineers that are working on the train break at a particular amount of time. So this is essentially incorporates our main neural network automation system, and essentially is the part where we reduce the actual time taken by the engineers to fix a particular train break from around 2 to 3 hours time into less than 15 minutes of time. So basically, these are the main job cards that a user engineer has to assign to, and this is the fitness report generator, which is basically uses neural network and uses a deep learning model, which is custom trained on a dataset called the Metro PT3 dataset, and this is basically used to train our DL model on accurate parameters. And we essentially, the engineer is going to be taking these parameters one by one from the train breaks, and then they're going to be predicting and generating the report. This essentially what used to happen is we used to have to look into a lot of logbooks, silos, spreadsheets, etc. And right now, with the help of our application, we are making sure that we can achieve this amount of accurate analysis of the train breaks in no more than 5 seconds in development mode, and that will amount to less than 15 minutes of time when we actually deploy the model on either AWS EC2 standards or AWS S3 buckets. We can also see that the job cards that have been analyzed over here, to maintain a proper record of it in both hardware and software basis, we have actually enabled the way to sort of preserve those job cards so that we can export them into PDF and save them accordingly. Now we move on to the Locopilot dashboard, which is targeted towards the people who are actually running their metro trains themselves. This is basically like a companion kind of dashboard portal where we are essentially taking the data of whether a train break is accurately safe or not from the actual drivers of the train break of the trains, which is the Locopilots, so they can actually mention what problems they're facing and with the train break ID, and that will be demonstrated likewise into our main dashboard. And as you can see, the source is the Locopilot over here of Train 590, as we have input into the Locopilot dashboard, and it appears in the high-level overview of our application, which is in our admin dashboard. After that, we move on to the employee dashboard of the section, where we essentially means that we can actually check whether or not that with an employee, which is basically an engineer or a maintainer or anyone, can actually view whatever job cards or whatever tasks he has been assigned to, and that is how a person. And this is exactly where our hardware also comes into play, which essentially is incorporated with this particular dashboard, where people can go there and check whatever jobs they're assigned. Finally, we come to a two-factor authentication verification system. So basically what happens is this particular dashboard is maintained by the quality assurance team of any train validation rec. As you can see that currently the states are pending and ejected, and apparently the 559 that we have said that these that was having cleanliness issues, that request, the job request, is going to be shown over here because it is a pending request, and we have not yet approved of the fact whether or not the quality assurance team has said that train is ready to be moved into the public transit or not. As you can see, we have rejected that particular validation thing, and Rec 559 is currently rejected. So that means that job is going to be assigned to another person. This assignment is being done by the celery pipeline, which is essentially queues all of the job cards into a celery distributed queue, and that distributed queue, using the round robin algorithm and using the Redis message broker, we are essentially assigning it to all of the employees in their car shed, making sure that nobody is overworked or nobody is underworked. Everybody is adequately equipped to carry out his or her performances and duties effectively and immediately, because we do not want people to be waiting without a particular work to do when they are in the site. This is our hardware model that we've incorporated with the employee dashboard section. So basically what is going to happen is, in the case of unavailability of Wi-Fi or internet accessibility issues in the car shed, since we're not sure that it will work all the time, so essentially the job cards can be shown in the form of a LED script, and we have used Arduino IDE and a C++ for this. And as you can see that against a particular job card, we can see what the job card issues are and whether or not the job card has a status, which is status being fit or unfit. We finally move on to our mobile application. The mobile application is a companion mobile application which is written in React Native, so it is both available for iOS and Android, and this basically is targeted towards the consumers, which are the main commuters or the passengers, because their input is absolutely essential for any kind of automation software to be rely on effectively, because most of the data of a train rig being faulty or not, or fit or unfit, it will come from the passenger dashboard, because they are going to be the people who are actually riding the train platform, train itself. So their nuance and their input is very essential to us, and therefore we have made that feature possible using a mobile application, because it is extremely easy for them to access it, other than having to move into a proper particular web application just to make a call plate. And as you can see, so passenger, as we write it, launch the complaint in the passenger mobile application, we can see that the complaint immediately is received by the admin dashboard, and hence the admin is able to understand and know what the actual problems are. And as you can, and as well as that, we have implemented a search and sort function in the actual complaint jobs and validation section, so that it is easy for the admin to sort of skim through all the required and non-essential or essential requirements and job cards, and that is how we have implemented it. Thank you.